We shall begin lightning talks by explaining how lightning talks work, and then we'll dive right into it. So just in case someone is not familiar, the idea is that you have 5 minutes to give a talk, and after that, that's it. You hit the 5-minute limit, and you are out of here. But we want to give the lightning talk presenters a little bit of time to make sure that they know the time's up. So when there's 1 minute left, I will raise my hand. You don't need to do anything quite at that point. But when there's 10 seconds left, I'll put up, well, maybe I'll put up 2 hands. I'm not gonna do that right this second because my shirt will come up. So then everyone's gonna start like doing a little bit, light applause, and then we're at the minute then full-throated applause. How's that sound? We're good? Cool. We have 11 lightning talks today, which should hopefully bring us right to the end of the hour, and then this will conclude this portion of the event. So without further ado, Keith is going to present his topic.
Okay, my timer started. Okay.
Your timer is started.
All right, so my name's Keith Fisk. I'm from Crunchy Data. One of my projects at Crunchy Data that I work on a lot is monitoring. And one of the primary things that we've been running into lately with monitoring is people keep wanting to run queries that get slow, or even just basic things like a database size, but then you have like a multi-terabyte database, and you just do a simple size query on Postgres, and that can take longer than the timeout for what Prometheus's usual scrapes and stuff are. So I started turning those things into materialized views, but then you need to refresh materialized views. So I kind of just decided to make another extension, kind of centered around monitoring, where I'm just turning all of the metrics into views inside the database, and they're inside this configuration table. So just trying to do a quick overview thing here. So the basic idea is slow queries are turned into a materialized view. Other queries that don't necessarily need that, like pgstat activity, something more real time, just turn that into a view as well, and make the external thing that's collecting the metrics, make that as easy as possible. So instead of putting all the complicated queries and slow things inside, and this is for Prometheus primarily, into Prometheus, I'm putting it into the database. It's got a scheduler in there. You can tell how often you want to refresh it. And actually provide the metrics to say, is this actually refreshing? Is it running on time? Am I getting things up to date? I know. So I'm turning this into an extension, hopefully have it released sometime next month. The repository that this will be on is the pgMonitor repository at Crunchy Data. So the next version of version 5 of pgMonitor, please come check it out. And if you think it's a good idea, I'd appreciate any feedback on something like this. Thank you.
Thank you. Wow, well under time. Yeah. Could we break the world record for fastest lightning talks? We shall see. All right.
So, well, data is beautiful as presented, but there are other ways to exploit this beauty, and that's what I have tried. So there is rhythm in the data. There is balance, because there is so much variety across the columns, and then we store the data row by row. I was thinking of ways to exploit these properties so that we can create beautiful abstract designs. And so I wrote a Python program. As part of me learning some Python work, I did this and also tried to do what I wanted to do. What this does is basically it takes one directory, one subdirectory under the data folder, and then collects all the files from it. The largest file becomes the base for the image or the design, and the other files add beautification to it. Well, that's the part which beautifies it more and uses the smaller files. And then I convert that raw data into almost square kind of bitmap image, and then save it to the disk. So here is what I get. And incidentally, the first image looks very similar to the carpet that we have here. Well, this is pgbench data, by the way. Well, these look OK. I was disappointed first, but yeah. The best that I have got this. and which kind of encourages me. This is much better than the earlier ones. There is a lot of variety. It's still beautiful. So I'm going to continue these experiments, either add more ways to do, add more beautifications, maybe break the horizontal lines into waves by using those beautifications. And the next thing I'm trying to do is convert these bytes into music by using them as notes. But anyway, those are my efforts. If you have any ideas other than this, please let me know.
Actually, it also reminded me of the magic eye for those of you who did those puzzles back in the day, which I was always bad at those, but it looks really cool. All right, so Peter, you're up. Devrim, you're on deck.
All right. Hi, everyone. So I'm Peter Eisentraut. I'm a Postgres hacker, and I'm also a member of the working group that works on the SQL standard, and I just want to give a quick update what's been happening there lately. So this is kind of a picture of how that looks, if you're interested. So, a bunch of database nerds in the room and talking about stuff. And so since some things that happened in the last 12 months, so I gave, so a similar lightning talk last year. SQL 2023 was published in June 2023, so shortly after last year's conference. A lot of what's in there was already put in Postgres 16, and some of the new features in Postgres 17 are also sort of driven by that. And so we're well on top of that. Another thing that happened was that a brand new standard for a brand new database language called GQL was published this year. So that's for graph databases. So that's not really going to affect us directly, but it's kind of interesting to know that those kind of new kind of stuff still happening. And then a few other projects. Don't want to go into all the details, but the work on the new versions of SQL and GQL has already started. So as tentatively, it was decided that we're going to aim for new versions at the end of 2027. Obviously, that can change, but it's kind of maybe a useful thing to keep in mind. So the working group meets 3 times a year, usually in person, or you can also dial in via Zoom if you can't travel. And then there's occasional interim web-only conferences as necessary. So these are the meetings we had recently. The next meeting is just in 2 weeks. So this would be the future slide of what's new in SQL 2027. It's early days now, but just so kind of some examples of work continues. One thing that was done pretty early on was this is actually correct if you think about it. The minimum maximum identifier length was increased to 128 characters. In Postgres, we're currently at 63, so we potentially have some work to do. The other thing that's new is this functionality to add defaults to the cast operator if you have errors. That's something that was actually driven out of the discussions we had in the Postgres community. So that's in the working draft now, and maybe we should implement that now. And then the last one is sort of a thing that can support simpler assertions. Can't go into the details of that. Some new topics that are currently being discussed, and I have 2 calls for help here, which is why I'm really up here. So if you're interested in, have knowledge on the topics I'm going to talk about in just a second here, please reach out to me, ideally in sort of this week or next week, because as I mentioned, the next meeting is in 2 weeks. So first topic there is, vector stuff. That's obviously a sort of current interesting topic, and just to kind of show an example here, the different SQL database systems are adding support for that, but just kind of illustrate why maybe talking about standardization might be useful. That these different systems have a vector type that sort of looks the same, but if you want to do distance calculations, they all have different syntax. So maybe we could talk about sort of organizing that a little bit. And there's other things to talk about, sort of how do you decide what the internal type in the vector is and so on. So these are all kinds of things. The working group has asked me to give a report or a presentation on what's going on in the Postgres land on this, right? And other vendors will do the same. So, and then we'll, I guess, sort of mix it all up and come up with a standard. So if you have any interest in that, or want to give me something to present or have a question, please reach out to me. The other thing that's being discussed is maybe kind of interesting to provide a more document database-like experience on top of relational databases. So maybe, for example, this could look like that you have a sort of special JSON table that just has a JSON column with an ID, and then you would have additional driver support on top of that to have a sort of maybe a Mongo-like experience with a relational database underneath. And I know this has been done in Postgres a few times ad hoc, so if you have interest in that, again, reach out to me and then we can see if we can do something there. So those are basically my asks for help. Other than that, if you have any questions about this topic at all, please reach out to me or I'll be around. And that is it. Thank you.
Okay, Devrim, you're up. Lukas, you're on deck.
Thank you. So this is going to be a talk about the state of the Postgres RPMs. If you are using the Postgres RPMs, that's me. So before we start, yeah. But now it's 75 slides right now. So I'm one of the major contributors. I do the Postgres RPM packaging. So if you are using one of those RPMs, if it's broken, it's not me. It's not broken, it's me. And nowadays, I'm also DJing. Yeah, like this. But the talk is actually, the title is Oops, because that's what we are doing in the last few years. So this is the state of the Postgres RPMs. First of all, we have Postgres 17. Don't use in production if you are not Magnus. Or Postgres 16, which is great. So if you say just yum install PostgreSQL on Red Hat 7, it gives you 9.2, which is another major pain point for us. But anyway, don't do this. Use our repo. So this is the platform support that we have. We have Red Hat 9. We are going to retire Red Hat 7 next month, hopefully. And we support Rocky, Alma Linux, Fedora, and SUSE. But some people may think that it's not hard, but it's really hard. As you can see in here, inside the spec file, we have lots of various dependency names for various other platforms, including different versions, and different names in Fedora. So having a single spec file is a challenge for us. So we have 134 common packages, 150 non-common, blah, blah. Unfortunately, we have 299. I'm really stressed today. It should be 300. I need to add another package today. But nowadays, the problem is users want more. Of course, I would like to see good feedback. Like, it worked like a charm for my customer. Customer was impressed. It was another bug fixed in 8 minutes this week. But then I have the biggest feature of the RPMs is so am I evil? This is a Metallica song. So this is one of the emails that Joe Conway sent to the Acres mailing list last month, I think. Yeah, I'm not injecting any code to the RPMs. Okay, you can trust me. But then, of course, we have lots of problems. Suddenly Red Hat decides to partially shut down its source code, tarballs. And then there is another problem because since this has been done, the RPMs built on one platform doesn't work on the other. It's gone. We already had some issues with CentOS 8. It was gone. There are lots of derivatives exits. Can we support all? It's another challenge because some people from Alma Linux sent me a patch about removing the space between Alma and Linux. And at that moment, I was, why worry? Right? There is nothing I can do. I can do something about it, yes, so why worry? Is that all? Of course, no, because I'm always good at breaking things. I used to break website, and they revoked my commit bit. And last year, I broke the JS stack really badly. Like, everything is broken. Like, everything was broken. And, like, this is not working. And at that moment, I was, why worry? And then the regular problems, the LLVM problem. Every 6 months, we have this problem. And it's broken support in Fedora 40. Because Red Hat releases their minor versions 1 day before our release. It's a problem. New LLVM, blah, blah, we do it. At that moment, I'm drinking Guinness. Why worry? And of course, I have great friends because they encourage me to do the things. do not give me beer until it's done. At that moment, I'm DJing. Why worry, right? And these are the tarball names from each individual package. They don't give any name, just real version number, blah, blah. And there are lots of slackers. They don't update their packages. This is shame of the list for Postgres 17 for now. Okay, we are getting there. We are getting there. So, and someone says, I want to release a new version every day. Shut up. So seriously, things are mostly stable, trust me. We do the timely updates in the Postgres repo. Lots of users do it. And thanks Enterprise DB. I made it!
It's okay, Lukas, you can come up. You're next.
All right. Microphone working? Wonderful. I have just 9 slides, so this should be much, well, faster, I don't know. Less time per slide, more time per slide. I just briefly want to talk about pgQuery, which is a project that I started with a colleague of mine back then, almost 10 years ago, which lets you use the Postgres parser outside of the server. So this is available today. It's useful to people. In this room, you probably have a running server, but if you don't have a running Postgres server because you're parsing queries in your application or in your tool that you're building, pgQuery helps with that. So this was the original post back then. Don't use regular expressions, but you're probably maintaining your own parser if you're not using something like pgQuery to parse Postgres queries. pgQuery is a C library. It gives you either a JSON struct that looks really hard to read. It's essentially an internal Postgres node structure with a nicer format than node2string, I imagine, in my opinion. We also do protobuf these days. So the idea behind protobuf is we have a bunch of language bindings. You want to work with actual structs in your Ruby, your Go, your Rust. And so there's nicer versions of working with the parse tree. And then lots of people are using it, which really surprised me, which is part of why I'm here talking about this, because I think it might surprise you all that people want to parse queries outside of the main Postgres server. And so just an example, Google uses it for their Harbor Bridge project to migrate people, I think, from, well, this is Postgres to Spanner for some reason. GitLab uses it to normalize queries for internal error reporting. SQL lint can lint your SQL files. There's SQL C that lets Go developers compile queries at essentially build time so that they have kind of type definitions and whatnot based on their queries that are parsed. And then also we have a bunch of bindings. There's lots of people in the community that maintain bindings for that C library so that people can use it in Python. We ourselves at pgAnalyze maintain Rust, Ruby, and Go. And then, for example, there's pglast in Python, which is a very popular binding as well. Now, most recently, we did add support for Windows finally. That wasn't us. We're just taking a Postgres source, right? We just didn't add the necessary port headers, but now people that want to, parse queries on Windows, they can. We can parse PGCQL to the extent that working with raw PGCQL parse tree makes sense. So definitely lots of caveats there, but people do find that useful because they want to build tools around PGCQL. And then we also have a deparser, which some people make use of that to essentially parse a query, change it, and then turn it back into something. So really simple example here in Go, I have select 42, then I'm modifying that parse tree, in this case the Go struct, and then I'm deparsing it, and I'm getting a string back. And really the point of that is you might want to modify queries in a way that is actually reliably working in terms of parsing and deparsing. It passes all the Postgres regression tests in terms of parsing them, deparsing them. It's still the same AST afterwards. And that's really it. What's next here is we're committed to maintaining this. We hired somebody on our team to work at least part-time on maintaining pgQuery. We are evaluating how to reduce the diff to the actual raw Postgres source. So for example, the node func improvements that were made recently are actually quite helpful to make these customized out funcs easier to maintain. And then I am definitely open to discussing how we could maintain this differently. At this point, I'm not sure if this makes sense in core. I think it works actually pretty well as an independent project, but certainly, that would be something we could discuss is, should this be part of Postgres? Should there be a library that's just being shipped, that's the raw parser? Again, because people do find it useful, and that still surprises me. So, thank you.
Thank you, Lukas. All right, Bharath, you're up. Alena, you are next.
Hi, everyone. My name is Bharath Rupireddy. I'm Postgres contributor and a senior software engineer working on the AWS RDS open source team. Today, I would like to talk about new table access method for multi-inserts. First, we'll go over the motivation. and then the key idea behind the multi-inserts for heap access method, and can we use it for any other commands at all. And I would like to show you where we are today with the patches. Okay, so today copy buffers multiple tuples and then inserts them at once. So yeah, it has advantages, which we'll look at in a second. We are also looking for reusing that logic for various other commands. And also, we received a feedback for having scan-like APIs, like you begin the insert operation and you do the insert and then you do the end. So all the bulk insert state logic and everything goes to the begin and end functions. And we also want to have the flexibility, like different access methods can choose their own buffering strategy. For example, columnar versus row storage. So let's look at what's the main idea behind the heap access method when it is using multiple inserts, right? So when we are inserting multiple inserts, multiple tuples, and if we can write all of them into a single page, so we can write less wall and we can take less locks. That's the main idea there for heap. Let's see if we can, reusing this logic, multi-inserts, for any other commands, give any benefit for us. So create table as command. With the new table access methods, so the test case is 100 million tuples and 2 columns, 1 int and 1 float. It got faster by 36% with 64% less wall. And create materialized view. It got the same use case. It got faster by 51% with 68% less wall. And refresh materialized view, it got faster by 52% with 49% less wall. And the table rewrite operations like alter table, add columns and drop columns, stuff like that, got faster by 34% and with 60% less wall. And again, insert into select got faster by 47% with 62% less wall. And lastly, the logical replication apply got faster by 22% with 69% less wall generated on the apply side. Yeah, there is patch out already. It is at version 21 right now. And thank you for those who have reviewed so far. And yeah, it needs more review, and any help is welcome there. Thank you so much.
Right, Alena, you're up. Hannu, you are next.
Hello, everyone. My name is Alena Rybakina. Sorry, I missed information in this slide. And I would like to talk about vacuum statistics. To be honest, I sent the letter with a patch about to store information about vacuum statistics, and I'll a bit explain you why it is important. We all know why vacuum is important, I suppose. It prevents the problem which is related to table and index bloating, emergency freezing, when we have wraparound problem, and it updates information about visibility map. But unfortunately, vacuum has some disadvantages, like so it works well when we have append-only tables, but if there are tables are high frequency updating, we might have some problem. And another problem which is related to the fact that we have no visibility map about indexes, so vacuum scans the index completely. And we have some settings for the vacuum, and it helps us to determine the aggressive functionality for objects of the database, and it is important for administrator to have a balance between vacuum's useful actions and the minimum of the overhead of its workload. And so we have some statistics for vacuum to analyze vacuum functionality. And it is number of vacuum passes through tables, operation data from database progress vacuum, and logs and information in logs. But it is not enough to have to analyze vacuum functionality for a period, for example. And so we suggest collects information about vacuum, as I remember before. And besides, this information is collected by vacuum, has been collected by vacuum already. And it is buffer statistics. You can see it in logs, for example, val statistics, and number of tuples removed that was removed, dead tuples, and system time, user time too. And we can store this information to cumulative statistic system. And so it helps us to have a vision about vacuum workload for the objects, and it helps us to improve vacuum tuning. And so also authors of this patch, not only me, but Andrei Lepkhov and Andrei Zubkov. And you can find this link on this thread like that, but you can find it through searching on information about vacuum statistics only. So thank you very much.
Hannu, you are up. Yurii, you are next.
So there is a thing called PG test timing in source bin, which is available to see how much overhead it is to get timings for things like block timings and other things. And I read the description from 9.2, it was from 2012, which says that good results will show most individual timing calls take less than 1 microsecond, and even less than 100 nanoseconds. This is from 2012. Only change I saw in documentation is that it was now listed in the order from fastest to slowest. It used to be from slowest to fastest. So I instrumented it to actually show it in nanosecond resolution to understand where the timings are. And for Intel, they are mostly under 32 nanoseconds or 62, so it together is already 99% was there. In case of Emerald Rapids, it was between 32 and 46. Again, almost everything was there, so there's very, very few outliers were there. Then in AMD, it was again below 32, again 99.9. And interesting thing was in Ampere, it was about, what was it? 12% was below 1 second, below 1 nanosecond, which actually means 0. So running them in loop, you could get 2 same values in a row. And the reason is that they are exposed differently. In case of x86, x64, they come from calling assembly instructions in ARM. They are exposed as a register content that is updated in the background at its own pace. So you can get lots of same values. And in this case, it was 12% same as the next one were all below 64 nanoseconds. So again, everything is really fast. I couldn't really find any modern CPU where the 99.9% was above 64 nanoseconds. And then I also did some, started actually measuring using RTSC instruction directly, so I got the exact values in ticks. Ticks is a weird thing that is defined as some number that doesn't depend on frequency. In case of AMD, it was either 10 or 20 ticks always. I only measured exact values up to 64. And in case of Intel, it was for some version it went into 2-tick intervals. In some others it was in 1-tick interval. So it's always really fast. And so when making decision whether to enable it, because by default Postgres has it not enabled in most cases, I guess you always can enable it. And that was more or less that I wanted to share with you.
All right. Well, you're right. I have to tell you that you're up since you're clearly here. Mohammad, you're on deck.
Hi, everyone. My name is Yurii. I'm with Omnigress. We develop a lot of Postgres extensions, and we found that some of the testing methods that were available for our extensions are effectively insufficient. So initially, we started with pgregress, just wrote a lot of tests. But the problems were, first of all, they were unstructured, so you would have to read, the SQL input that goes into those tests, and you had to write, you had to run them and basically see what's being spitted out. Sometimes the test would change between the versions of Postgres a little bit, so that was not pretty either. And it was really hard to figure out where does one test and the other one starts. How do you manage transactions and do all these things. But when it got really, really complicated is when you're testing extensions that have data types that have binary encodings, because everything in pgregress is tested through text, there is no way to test the actual encoding and decoding of the types. So we developed a small tool called pgyuregress, and Y stands for YAML. And it starts pretty simple. You can actually have something as simple as this, just a list of tests, and starts with a simple test that just selects something. And if there's nothing else, it just tests that it runs. There's no error. And in fact, it can be simplified. It can be just a single line there without a name. And it works as a tab, so test anything protocol test runner. So it will run tests and tells whatever fails. And as I said, it can be further simplified as just a string if you're not naming it. What's interesting about it, you can start specifying results and see what results come in, and they become structured, so you can have a list of results, and in every result you would see what are the actual expected results. As you can see there, results, there's a value of 1. And it gets very interesting when you start creating more modern applications that use JSON types. Because YAML is also a JSON, you can actually specify inputs and outputs as YAML, so you don't have to pack them into a string and unpack them from a string and expect certain formatting. It will just do that automatically for you. You can test for failures, so what errors are to be created there, so you don't have to, again, write it, expect the output of a particular format from pSQL. You can specify the severity of error, what's the actual message, so all kind of depth. You can test negatively so that they should fail and things like this. And you can do things like multi-step tests. So basically creating a transaction with multiple queries and see what's happening with them, whether they fail or not, whatever results they're getting. You can group them without transactions as well, just logically, if there's a set of tests that you want to test that relate to a particular topic. And you can, by default, the tests are not committed, so they're always transactional, but you can make them committable, but just specifying that the commit is true. You can test for notices, especially when you're debugging your functions and you want to see what's happening with them. You can test that it should produce certain notices. And you can do that actually in transactional tests as well. As a promised binary format, so you can actually test what is the binary value that comes out of the particular value that you're returning. So in this case, it's a Boolean, so we're getting 1. And you can pass binary parameters as well, so you can test whether your implementation of a particular type is decoding it correctly as you expect. And then the usual things. For example, sometimes you can skip tests if they're not ready or if something is broken. You don't have to do anything complicated where you would have to comment things out. That's pretty much it. So the basic idea is that they're very structured. They're allowed to test against JSON data types, transactionality of and grouping of tests, and binary format. So that's about it. Yeah, that's it. It's short one. It is lightning.
It was it. It wasn't about it.
Yeah.
Great. Mohammad, you're up.
Yeah, thanks.
And Yuki, you are next.
Yeah, while it's coming up, my name is Mohammad Dashti, and I'm a software engineer at CrystalDB. As much as all of us love Postgres, and we are here because we are contributing to it or like the products, and we know it's eating the world, right? But still, it's not a secret that running in Postgres instant reliably is hard. That's why we have so many books written around the subject. We have many great DBAs, many of you in the audience here working in this area. But compared to the speed that Postgres is, making progress and, it's being installed around the world, we don't have the DBA expertise, working at the same speed, and still it's a scarce resource, basically. And in the database industry, starting from late 90s, people have worked on this, trying to automate many of the DBA tasks that could be automated, like starting from Microsoft, working on SQL Server, Oracle. But even with all this effort today, we are not at the reliable state of these things. Even, talking to Oracle DBAs, they usually tell you, okay, turn off all these automated tuning features. It's not reliable, just shut them down. And this actually is ironic, right? These are built, spent many hours of software engineering work to build the tools, but not being used, right? And in our community, we have built-in tools like AutoVacuum already in Postgres and other tools that help us doing monitoring and automating everything that is to help DBAs, basically. But still, there's some way to go. We are now in 2024. We see self-driving cars running around, some U.S. cities like in Phoenix, if you go, or San Francisco. They're already doing many successful driverless, trips around the city, and that's the stake that people expect in automation. Basically, any kind of task that can be automated, including the database administration, people expect it to become driverless, right? This is what we want to get to. And at CrystalDB, we are a startup. We are devoted to contributing to Postgres, and we are hard at work to make this product called pgAutoDBA, and we are going to open source it soon. But we also need your help. If you are a DBA that you are interested to offload some of your mundane tasks and do more interesting DBA work in your free time, please reach out to us. We can talk to try to figure out what are the things that are top priority to put into such a product that everyone can use in the community. We are not going to keep it for ourselves. And then for developers, if you are a developer shop and want to focus on app development and rather than DBA work, again, talk to us. We can probably help you there. That's the main thing. Thank you.
Thank you, Mohammad. Hey, Yuki. And believe it or not, this is going to be our last lightning talk. That is, like I said, I think we're going to hit the new speed record here.
Thank you for this occasion. I'm Yuki Fujii from Mitsubishi Electric, which is a Japanese manufacturing company. Tomorrow, on conference session, I want to discuss about the patch named partial aggregate pushdown. Sorry, this small. Sorry. For getting attention of many people, today I would like to introduce the overview of this patch. This patch allows Postgres make scale out of aggregation based on FDW-based sharding. Recall overall mechanism of parallel aggregation in one server based on parallel query future, current parallel query future. In this case, in Worker, transition process is performed for each record. Updates the state value. This is the flow of the averaging processing. In this case, state value is a 2 array of sum and count. And after that, Worker transmits the state value to the coordinator. This is important point. In coordinator, the final process generates return value from state values received from workers. In this case, final process returns the quotient of sum and count. Challenge in built-in sharding, FDW-based sharding, as in ours was built-in sharding. In this case, the state value must be expressed as a return value of an aggregate function, because coordinator and workers must federate through SQL interface. That is FDW's constraint. My proposal is defining new aggregate function which returns a state value. We call a partial aggregate function. In averaging case, the state value is the return value of a new partial aggregate function, such as AVGP. This is a performance evaluation result used a query, TPCH query 1. Aggregations in our proposal, aggregation speed increases proportionally to the number of workers, this blue line. In other hand, existing part, Postgres, this black line, aggregation speed decreases when the number of workers is greater than 1. The reason for that is because the existing Postgres requires transmitting all data, all target data from the worker to the coordinator. However, in the last year, we received some important comments from several committers, including Mr. Haas and tomorrow on conference session, we would like to explain to the response to this comment and discuss how to advance this patch. Thank you.
Thank you. And that's a wonderful plug for the unconference tomorrow as well. So before we all go off for dinner, a couple of announcements. First, thank you again, all Lightning Talk speakers. That was awesome. So speaking of feedback, the general conference feedback is now open. So it asks a whole host of questions such as, do you like the conference? Where should we have the conference? And more. So please give us that feedback because that really does help drive like what we're going to do next year. Let's see. So tomorrow morning, breakfast starts at 8 a.m. and the unconference starts at 8:30 a.m. So show up for breakfast, show up for the unconference. It'll be a good time. Last but not least, it's dinner time. Make some new friends. I think that's the theme of the conference. Find someone you haven't met before and go out for dinner. It's apparently a beautiful sunny day in Vancouver, so it'll be a beautiful sunny evening, so have fun. We'll see you tomorrow.